Next, we're going to talk about how to use the definition of a midpoint in a proof. So if I told you that M is the midpoint of XY, well, if we know M is the midpoint of XY, that means that it's dividing that segment equally into two congruent parts, into two congruent segments. So segment XM and segment MY should be congruent to each other. Notice my equal sign is wearing a hat, and so my segment's wearing a hat. Those two segments would be congruent to each other by the definition of a midpoint. That's what it means for M to be the midpoint of that segment. And the reverse is true as well. If you know that those two segments are congruent, if you know that XM and MY are congruent, that means that point M has to be the midpoint. So it can go in the opposite direction as well. If segment XM is congruent to segment MY, then that means that M is the midpoint. Or vice versa. If M is the midpoint, then that means that those two segments have to be congruent to each other. So these definitions are, if you remember from a couple days ago, these definitions are biconditionals. They're true in both directions. So definition of midpoint and definition of angle bisector both work in both are true in both directions. So if something's a midpoint, then the two segments are congruent. If the two segments are congruent, then it's the midpoint. If something's an angle bisector, then those two angles are congruent. If the two angles are congruent, then something's an angle bisector. It's true in both directions because it's a definition. Let's work an example. Proof. Given that V is the midpoint of SW, segment SW, and W is the midpoint of VT, so this is our given. If V, I'm going to take it one thing at a time. I'm going to just take something out of my given and attack it. If V is the midpoint of SW, that means that V is dividing that segment into two congruent segments. So I can say that segment SV and segment VW should be congruent to each other, and that's supposed to be just one tick mark, but my touch screen is being silly. I don't want you to think that it's two tick marks. I'm going to erase it and try it again. Okay, segment SV is congruent to segment VW. Better, much better. Okay, so segment SV is congruent to segment VW. And then it also tells me that W is the midpoint of VT. So that means that WV and WT are going to be congruent since W is the midpoint of that segment. So I can put that in my proof. VW needs to be congruent to WT. And why am I allowed to say that those segments are congruent? My reason is, well, that's the definition of a midpoint. That's what it means for that point to be the midpoint. Those two segments have to be congruent to each other. That is the definition of a midpoint. And so now I notice I have SV, that's a term. I have VW, that's a term. Oops. And then I have WT, that's a term. I have three terms. 3 starts with the letter T. T for transitive. So by the transitive property, I can say that segment SV has to be congruent to segment WT. This VW right in the middle sandwiches it together by the transitive property. There we go.